All right, so systems of equations, we've got a couple different types here. The majority of what you'd have to do are going to be a linear with something else, and you'll always use substitution. So this is a linear with a circle. You should know that this circle has the center at 3, -2, with a radius of 4. So 1, 2, 3, 4 up, 4 to the right, 4 down, and 4 to the left will give you an approximate. And then this is a linear, which we'd have to solve for y to graph it. To do substitution, you're going to have to solve for x or y anyway. Usually you want to do whichever one's easier to solve for, whichever one will not result in a fraction. Truthfully, neither of them will here. I'll solve for y just because that's usually what we're a little more used to solving for. So I'm dividing that 2 away from the y, so I get 5 minus x. So visually that's a y-intercept of 5 and a slope of -1. So our answers are going to be that point and that point. But algebraically, we have to do the substitution. So in equation 1, it's a circle. Equation 2 is the line. I always solve the linear for a variable. And then, since 5 minus x equals y, I can plug it in up here. So I get x minus 3 squared plus 5 minus x plus 2 squared equals 16. And then I'm going to clean this up. So x minus 3 squared plus 7 minus x squared equals 16. And then it's all in terms of x. So just solve it. It's quadratic. Square this out. Square this out. Get everything equal to 0. So on my left-hand side, I've got 2x squared. I've got minus 20x when I combine the x's. And then 9 plus 14 is 23, but I'm going to subtract a 16 over, and 23 minus 16 is 7. So I'm going to solve this I'll try to do it by factoring, see if it works. 7 and 1 is my only option. So what went wrong here? I feel like this should have worked out nicely. I don't believe it's factorable. 7 and 1's not going to work for me. So, quadratic formula. Negative b is... No, something's wrong here. Hold on one second. Let me think this through. Okay, I found it, and maybe some of you thought it when I went through, but when I squared this, 7 minus x times 7 minus x, it should have been 49 minus 14x, not 14. Systems are going to work out pretty nicely, so if you had to do the quadratic formula in there, that wouldn't have been good. So now if I do this, 49 plus 9 is 58. 58 minus 16 is 42. Now I can divide out a 2, first of all, on both sides. So I get x squared minus 10x plus 21. Now I get something that's factorable. X minus 7 and x minus 3. So x equals 7 or x equals 3. Now that's just the x coordinate. Okay? So I just found the 2 possible x coordinates. Find the appropriate y that goes along with each of them. So if you know x is 3, 5 minus 3 is a y of 2 here. And if you know x is 7, 5 minus 7 is a y of -2 here. So your answers are there and there. The next one is a linear and a quadratic, which the linear already is solved for y, so -2x plus 1 is equivalent to y, so it can replace the y down here. And then it's just a quadratic. Now, I don't really know what the quadratic looks like, but I do know that this is a y-coordinate of 1 and a slope of -2. So the linear looks something like that. The quadratic opens downward. I do know that. But I don't know, is it going to hit it once, not at all, twice? So I'm not sure exactly how it's going to look, but we'll find out. So if I add 2x to both sides and subtract 1, because I'm solving the quadratic, plus 1 minus 1 is 0. So I can factor this, just like I did the last one, but this factoring is going to be not split the middle term or guess and check, it's going to be GCF. So if I pull out an x, I'm left with negative 2x plus 5. And tee it up. X equals 0, or negative 2x plus 5 equals 0, which will give me, divide by negative 2, which will give me x equals 2.5. So those are my two x coordinates. So it's crossing at x equals 0, and it's also crossing at 2.5. So this is 0 comma something, and this is, well, we'll say it's going to cross there. This is 2.5 comma something. So to find out, plug back in your 0. That'll give you a y of 1. So 0, 1 is the solution. And plug in 2.5. Negative 2 times 2.5 plus 1 is negative 4. So I get the other point right there. So the parabola must do something like this. And we get the two solutions. This next one is a system in 3 variables, which is not substitution. It's elimination 3 times. So you want to peruse your x coefficients, peruse your y's, and peruse your z's, and see what's the easiest to get rid of. And this one is clearly the y's. So you don't need any multipliers if you eliminate your y's. You just decide on my first 2 equations, am I going to add or subtract? In opposite signs, I always say to add. So x plus 6x is 7x. That'll cancel. 5z plus 2z is 7z. And 45 plus negative 10 is 35. On your second 2 equations, opposite signs, add again. 6 plus negative 2 is 4x. Those cancel. 2 plus 8 is 10. And negative 10 plus 72 is 62. So now I've gotten rid of my y's twice. I've done 2 rounds of elimination. My third round of elimination is picking which variable now is easier to get rid of. And the least common multiple would be 28, so you'd have to make both of these 28. Least common multiple here is 70. So whatever you'd prefer. I'll make these both 28. So this one gets multiplied by 4. And this one gets multiplied by 7. 7 times 62 equals 434. That's a big number. And then same sign on those, so subtract everything. So we're doing subtraction. So 28 minus 70, negative 42. 140 minus 434, negative 294. Divide everything by negative 42. And you get z is 7. Now it's a domino effect backwards. So if you know z is 7, we can plug it in there to find x. This is 70, so I'm going to subtract 70 from both sides. I'll get 4x equals negative 8, so x equals negative 2. And then these go back into an original. So x is negative 2 plus 3y plus, and we already knew z was 7, so 8 times 7 equals 72. So this is 4, so I have to subtract 4 from both sides. This is 56, so I'm going to subtract 56 from both sides. 72 minus 4 minus 56 gives us 12, so y equals 4. And there's your answer. So substitution anytime you have a linear with something else. Elimination anytime you have a 3-variable guy. So this would be substitution, where you throw your 2 to the x in for y. So 2x plus 2 to the x equals 11. Now this is tricky because this is an exponential equation with the variable and the exponent, but also there's a variable elsewhere in the problem that's not in an exponent. We unfortunately don't have the algebra skills to solve this. So if that's the case, we can't do it algebraically. They would never tell you to do this one algebraically because you can't. So then your default is graphically. So this is one equation to type into your calculator. This one would be another, but we've got to solve for y. So y equals 11 minus 2x. One thing I do know, just very quickly, we got an exponential growth, and we've got a y-intercept of 11 with a slope of negative 2. So something is going to cross. So if you go to your y equals and type in 2 to the x as equation 1, and type in 11 minus 2x as the linear equation 2. Zoom 6 will give you a standard graph. There's your exponential growth. Here comes your linear, hopefully, right there. There's your answer. Second trace, option 5, intersect, and then get your cursor over to the point of intersection. Enter, enter, enter. And your answer is an answer that needs rounding. So let's do nearest 10. 2.6 and 5.9 would be your answer. Okay, this next one is a system, but it's hidden in a word problem. So you got two different scenarios. Pedro, who's starting with 100 ants and his farm is growing exponentially at a rate of 15% per month. So from what we know about exponential growth, there's our starting value. It's growing at a rate of 15% every 1 month. So T in time will be 1 month. Bobby, second guy, starts with 350 ants and says his farm is steadily decreasing by 5 ants per month. Losing 5, losing 5, losing 5. That's linear. So he's starting with 350 and losing 5 ants per month. And again, T was in months. So for Bobby, we've got a linear decline. For Pedro, we've got, starting at 100, we've got exponential growth by 15%. They're going to cross. After how many months will they have the same? So after how many months, this is T, number of months, and this is the total number of ants. So when we solve this, we only want to answer the question how many months, we only want the x-coordinate. Again, it's going to be, it doesn't say algebraically, so we'll just use the calculator. So we'll type in our 100 times 1.15 raised to the x over 1 power. And on the linear, 350 minus 5x. Now zoom 6 is going to show me nothing. And the reason for that is because I'm only going up negative 10 to 10, negative 10 to 10. My y-intercept is 350, guys. So if I'm only going up to 10, I'm not seeing anything. This one has a y-intercept of 100. Not seeing it. So my window for my y-axis needs to change drastically. It's the number of ants, so I don't need a negative number. But I do need at least up to 350. I'll go up to 400. And then this is our number of months, so I don't need negatives. I'll just go 0 to 10. Assuming 10 months would be enough, maybe we'll go 0 to 12 just so we'll look at the first year. So there is our exponential growth. You can see the slight curvature on that. And then here's our linear decline. And the first year was enough because they're crossing. Second trace, option 5, intersect. Bring your cursor over. Enter, enter, enter. And we have after 8 months, they'll both have about 310 ants. To answer the question, 8 months. Okay, here we have a polynomial function, degree of 3, and this is an absolute value. So we're going to have something polynomial, third degree, positive coefficient, so it's going to have a positive slope. So something's going to start low and high, and then something's going to be an absolute value, but that got flipped upside down, so it's going to be some sort of graph like that. So we need to kind of see what happens here on our calculator just by typing them in, because we definitely can't do this. Oh geez. 8/9 x squared minus 16 over 13x plus 2. And then negative, your absolute values under your math and number, 0.7x plus 5. So I'm going to go back to zoom 6 just to get my negative 10 to 10, because the 350 window was for the ant problem. So there's our polynomial. And there's our absolute value. So we have 1, 2, 3 solutions. It's not going to cross again there. It's definitely not going to cross again there. So we just have to find those solutions. Now the solutions for when this equals this is just the x-coordinate. The y won't be involved. So when we trace these points, we want to steal just the x-coordinate. Intersect. We'll go all the way over, and we'll find this one first. Enter, enter, enter. Let's go to the nearest hundredth, negative 5.17. As soon as I see a crazy decimal answer, I immediately go back and say, what are we rounding to here? Second trace, intersect again. We'll go to the next solution where they're crossing. Enter, enter, enter. X equals negative 1.13. And lastly, second trace one more time, intersection, go over here, enter, enter, enter. 1.75. There we are. Okay, and then our last one here, this one starts off like, just solve the equation. Well, again, it's kind of like this one. It's an exponential and a linear, but this one started as a system. This one doesn't start as a system, but you almost have to treat it as one because you cannot solve that algebraically. So we're going to treat one equation like this and the other equation like the linear, and just type them both in, 5 to the 2x minus 1, and just 3x plus 1. Y-intercept of 1, negative 10 to 10 should be plenty. Here's our exponential. Here's our linear. This one actually crosses twice. And actually, if we even zoom in negative 5 to 5 and negative 5 to 5, I think we'll have an even clearer look. There's one solution here and another solution there, so second trace. Option 5, we'll get this one first. Enter, enter, enter. So x equals negative 0.31. I didn't say what to round to here, so I'll just do the nearest hundredth like we did on the last one. Second trace, intersect. Go all the way over here. Enter, enter, enter. 0.91. Because our solution is only the x coordinate. And that is your review of systems.